Okay, hey guys. I wanted to try and learn some about supercapacitors. I have quite a bunch. These are really small ones, but I have like 4 big ones, which I wanted to try and try to charge them and see with my minimal equipment to see what we can do with it. This is to learn about these devices. This one is a 63 voltage and a 1000 microfarad capacitor. So I can charge it up to 63 volts, which I don't have, but we can charge them nevertheless. I wonder, is it okay that I charge them just directly? Positive and a negative. The negative is pretty obvious. Let's first try to charge them at a very low voltage with my buck converter. I want to try and measure them at the same time. Let's see if there is already current on it. Current electricity, just no, nothing. This one is empty. It's not a booster for electricity, but yeah. Well. Let's first set it. I have 15 volt to play with. I want to set it at a very low amperage, like 50 milliamps. Let's say 5 volts to start with. I set that up. Now I want to be able to measure this. Let's take a darker color for the negative. Oh, they don't stick in there. I want to have a constant measurement. like this. Okay, let's put 5 volts and 50 milliamps on it. Go. 5 volts. Let's turn it off. The capacitor is not holding any current. Anything. I'm gonna cut this short. This is a negative, this is a positive. 5 volts. Doesn't hold anything. Right there. I'm gonna put this closer to the. Sometimes the board interrupts. Doesn't seem like. This doesn't seem to work. Let's put it. That capacitor isn't holding any current. That's weird. It should give off his current, no matter what. There is 5 volts coming in the capacitor. There is 5 volt going in, and it shouldn't be very long to charge this. It's not holding, not even a little bit. Let's try a higher voltage. Or a higher current. Let's try a higher current. Let's half an amp. It pulled for a second 10 milliamps. Oh, no. No, it doesn't hold any current whatsoever. Let's try a higher voltage. I can only give 15. 15.1. 14.8. And it doesn't hold anything. What am I doing wrong? You should charge it like that, right? I've seen the diagrams and on circuits it's doing that. This is 22 microfarads. A 22 microfarad 50 volts. The minus. What the? It should be charged in a split second. At least something. Now I'm pulling 40 milliamps, but it stops. So it's charged, it's full, the capacitor. And then when I remove the current, it's not giving off. It should be slowly, it should go to 15 volts, 14, 13, 12, and then keeps it at a certain voltage and then drops more. I'm gonna charge it a little bit longer. I found something in this circuit. Which is kind of my bad, because this buck converter uses resistors to discharge it. I looked up which resistor I needed to light up a red LED that's using 20 milliamps at 1.5 volts. So I needed a resistor of, what was it, 680 resistance. I have here a 680R, so I think that's a good one. Also have a 680K, but I think that's too much. We'll see. If the LED burns, the LED burns. So I want to wait. This is different rail from this one. So I'm gonna put this like that in this rail, and then the positive into here. Okay, I think this is right. I'm gonna use a darker color for the negative side. So the negative side is here. I think I can place it directly in this lane. Let's see what this does. So the problem I found was that I start charging those capacitors, which are good, but when I turn it off, it drops like a stone. And that's because I leave the capacitor still connected with the buck converter, and the buck converter has resistors on them to discharge the panel, so it's safe to pick it up and transport it and whatever, so you don't get a shock or you don't bump into other electronics. But yeah, there are resistors on it, so those resistors discharge those capacitors in an instant, while they don't really discharge by themselves. It was the buck converter. So if I put it on, the LEDs lighted up at 1.5 volt and normally 20 milliamps. It should pull 20 milliamps. It will be 19 or whatever. A second ago it was 20, so it will be 19. But yeah, because of the resistor is getting quite hot. Yeah, really hot. Smoking hot. But yeah, it will hold. The resistor is dropping the 15 volts up to 1.5 volts. Those wattages need to go somewhere, and resistors turn them into heat. But now, if I just shut it off, my resistors on the board and my normal resistor and the LED are pulling those capacitors. They are draining the electricity really fast. But the main drain is the buck converter. So now it's charged, the capacitors are charged. If I just pull it out, the LED stays on for quite some time, and the voltage will drop up to 1.5, where the LED is gonna use current all the time, but it's gonna drop really low now. The LED is still on. You probably can't see it. Maybe you can see it. The LED is still on, and it stays at 1.5, and this can go on for a long time. If I pull it out, pull out the resistor, charge the capacitors again, you're gonna see they're gonna drop like 10% or whatever, or maybe 15%, but then they're gonna stay on. They're gonna act like batteries. You can charge them real fast and you can discharge them real fast, but if you don't discharge them, they're gonna hold the current for quite some time. They are charged really good now, and it's gonna drop really slow, and at a certain point they're gonna hang. They're still gonna discharge a little bit, but they're gonna hold this charge for quite some time. If I of course put the resistor in between, it's gonna drop real fast, and the resistor is gonna heat up to 0 with the resistor. So basically what's in a capacitor, it's really simple and real complicated at the same time. The LED is on. Let's take a black marker and let's draw a capacitor. A capacitor is basically, to my understanding, but I'm a real novice and a noob in electronics, so you better learn from other people, but this is what I learned and think it is. This is a negative and this is a positive plate. So two plates with a conductive, so two plates with a non-conductive material in between, and in a capacitor these plates are rolled up like this without touching. I think they put some material in between. I've seen some, and it's black. It's blackish material, so they don't touch each other. So this is the negative and this is the positive plate. And that's just because to have a big surface on a small device. So this is probably 50 centimeters of plates in such a small capacitor. This resistor is heating up really good. And the more material there is, the longer the plates are, the more windings you have, the more capacitance you have. So that's my understanding. It's probably wrong, but that's my understanding. If it's wrong, I'll learn later. So this hangs, the LED is still on. I want to charge it and I want to see if I can make a spark. Now they are charged. Let's see if I can make a spark. Yep. I don't know if you have seen it. This is too much fun. Sparks and explosions and smoke. Autofocus. Let's spark this. They are welded together now. But that was really small. That was really a small one. I don't know. Okay. Those are capacitors. Let's test with the capacitor. Now probably it's gonna dim a lot faster. Yep. Use all 4 of them. Use all 4. So a lot of battery power. Actually capacity power. Okay, let's see what current it draws. Why is my LED out? Oh, I didn't turn on. Now they are charged all. Let's see how long that LED stays on. A little bit longer. Not very much longer though. With 4 capacitors. How can I make that more? Because that resistor is taking so much current away. And I need that resistor, otherwise the LED is gonna blow out. Let's test something. LED needs 1.5 volts, so I can charge those capacitors to 1.7 volts and don't use a resistor. Let's see. Let's say 1.6 volts. Set. Oh, why is that LED not burning? Do I need 2 volts? Let's take 1.6 or 7. take away that resistor. And just burn the LED with the electricity we have. Why is it so dim? I'm now pushing 2 volts and 10, 100 millivolts, and it's drawing 20 milliamps. And now let's see how long that LED stays on. Oh! That's nearly the same. I thought those capacitors would hold a much bigger current. It's still turned on though, that LED. It's really dim. You can't see it on camera. It is on though, just believe me. Can you see? So it stays on for quite some time, but really, really dim. It's still giving us 1.5 volts, those capacitors. So they still give us something. So yeah, interesting. Let's discharge these. Now I'm going to short them again and discharge them all at once. They should be short now. Oh. It was really weak. Oh, I'm shorting them the wrong way. Crap. Oh crap, did I break them? I shorted them with the polarity wrong. Crap, I didn't want to do that. Let's test again. No, they still hold the source. I'm going to do that one by one. Funny. 5 seconds. Then it's discharged. Yeah, that's somewhat the same. Yeah, no, I should use a button, but yeah. No, they still are all the same. So even if you do the polarity wrong, they still work. But I've read that you can actually charge them wrong and they stay in that position all the time. He's still holding charge. That one was holding a lot of charge still. I'm going to discharge them with this resistor on the buck converter. And now they're all out. Probably if I pull this, it's going to charge a little bit again. Really small amount. Okay. We played a little bit with the electronics and we learned stuff and understand stuff. Let's shut everything off and get ready for work tomorrow. Bye!